This is 2001 AMC 12, problem 15. An insect lives on the surface of a regular tetrahedron with edges of length 1. It wishes to travel on the surface of the tetrahedron from the midpoint of one edge to the midpoint of the opposite edge. What is the length of the shortest such trip? Note, two edges of the tetrahedron are opposite if they have no common endpoint. Let's first draw the tetrahedron. What is a tetrahedron? A tetrahedron is a shape where all the sides are triangles. So it has four sides. So it has not four sides. It has four surfaces or four faces. So each face is a triangle. So let's draw that. Since it's a regular tetrahedron, we know that all the triangles are equilateral triangles because a regular triangle is just an equilateral triangle. So let's draw a regular tetrahedron. Okay, so that's the first face. The second face can be more like that. And then, okay, let's just make that line also a dotted line. And then basically what we mean is that we start from the midpoint of one edge. So say we start from the midpoint of this edge over here, that's the midpoint, and we go to the opposite edge. So the only edge with no common endpoint as this line here, as this edge here, is this line, this edge. So we take the midpoint of this edge and let's just draw a line. So that is the shortest distance from this midpoint to that midpoint. But it says that an insect travels on the surface of the tetrahedron. And that line is through the tetrahedron, not on the tetrahedron. So what we need to do is we need to find the shortest route such that, for example, one example could be like that. So you first go around this front surface to this point, and then you go around the bottom surface through this line to the other midpoint. So what we can do, since this only involves the surface of this tetrahedron, is we can expand the tetrahedron. We can make it 2D. So we can show all of these sides. So since they're all equilateral triangles, we can do that, and let's say we choose a random side and we start with the midpoint. Yeah, the midpoint is here. So which side is the opposite of this side? The opposite of the side should be, so we know that these connect when you fold the tetrahedron together. These connect. Okay, so this is a bit hard, but no problem. Let's just take our time. So I think it should be okay, so I think it would be this edge right here. So we're going to travel from that point to this point. So if we draw the line like that, we want to find the distance of this line, or this line segment. We know since both of these are midpoints, so we know that this distance is equal, and we know this distance is also equal by some guesswork. So we know that these are parallels and these are parallel. So this is a parallelogram. We know that this regular tetrahedron has an edge of length 1. So since this is a parallelogram, this side is also going to be 1. So the answer is just 1.